Hello there, Mr. Sutton here, bringing you the Algebra 2 Honors 12-1 lesson on basic matrix operations. In this one, we'll learn how to add and subtract matrices, seems pretty basic. We'll also multiply matrices by scalars, and we'll be solving some matrix equations. To start off this chapter, we're going to define what a matrix is, and matrices is just the plural of that. So these are usually defined with some dimensions to go with them. So an M by N matrix is just a rectangular grid with some elements in it, and elements are basically just numbers. And this M by N business means that we have a dimensions where we have M rows and N columns. And that's how these are always written out. So for example, matrix A down here is a 2 by 3 matrix because we have 2 rows and 3 columns. So it's always important to note which is which here between rows and columns. Now there is one other thing just kind of worth mentioning, and that is if we say that two matrices are equal matrices means that we have the same dimensions and also that we have the same elements in the same positions. So for example, there would be a matrix that was equal to this one if there was another matrix that was a 2 by 3 that had all these same numbers in all the same places. So for our first example, we're going to be adding these two matrices together, or at least trying. The wording is kind of interesting here. It says perform the indicated operation if possible, and if not, explain why not. So it is possible that our answer might be undefined. So the thing to look for is that we can only add and subtract matrices with the same dimensions, which these do have the same dimensions, so we're good on this problem. But if you see a problem where you're trying to add or subtract matrices that are different number of rows and or columns, then that's going to be an undefined answer. So moving ahead with this one, how do we actually add matrices together? Well, it's actually pretty straightforward. We're just going to add or subtract elements that are in the same positions. So with that in mind, pause the video and see if you can add these together. Alright, so we're going to add the upper left elements first. So 2 plus 1. Then we have -1 plus 2. And then 3 plus 4. And then finally 0 plus -2, so 0 minus 2. And then we just have to simplify all this. So that's going to be 3, 1, 7, and -2. Here's a couple more examples for you for adding and subtracting matrices. Pause the video and try these two out. Alright, so for part A, these both have the same dimensions, so we can subtract them. We'll just subtract the numbers that are in the same position in each matrix. So we've got 2 minus -1, which is 2 plus 1, or 3. And then we have -3 minus 2, so that's -5 in the upper right there. And then we've got 5 minus 7, so -2. 4 minus 8 gives us -4. -2 minus -5 plus 5 is going to be 3. And then 8 minus 6 is 2. Next up, part B. Well, this one we have the same number of rows, but we have a different number of columns. So this one, since we have different dimensions, would be undefined. We just can't do it. For this next problem, we're multiplying by what is called a scalar. So a scalar is just a fancy name for a single number. So basically we're multiplying by just 2. We're not multiplying, and this is the key, not multiplying by another matrix. If we were, then there would be a totally different way of doing it that we're going to go into in a later lesson. But for doing a scalar, it's also pretty straightforward. Think of it as just kind of like the distributive property. We're just going to distribute this scalar to all the elements inside. So with that in mind, pause the video and try that out. Alright, so by distribute we mean multiply. So we're going to have 2 times everything inside here, which I'll show just by doing 2 times everything inside. You don't necessarily need to show this, but I wanted to show it the first time we did it. So going through and actually distributing, we've got 6, -4, 2, 10, 4, and 0. For this next problem, they've given us 3 matrices defined with variables here, and they want us to evaluate 2b minus c. So if they gave us just three numbers that A, B, and C represented, we would just plug those numbers in here and use PEMDAS. It's basically the same idea but with matrices. So we're just going to plug in the matrices and then evaluate that using PEMDAS. So make sure we multiply before subtracting and all that kind of stuff. So with that in mind, pause the video and see if you can apply that here. Alright, so for my first step, I'm going to replace B and C with these matrices that they represent. So I've got 2 times the B matrix here, this whole thing, minus C, so minus this whole third matrix, and then A just kind of was along for the ride, it didn't get used at all, and that's okay. Alright, so we're going to do multiplying first because PEMDAS, order of operations. So distributing this 2, we're going to have an 8 in the upper left, and I just rewrote the second matrix because it's not going to change for this part of the problem. And then this 3 is becoming a 6. Then we've got negative 14 and negative 12. Now subtracting, 8 minus 0.5 is 7.5. 6 minus 3.6, that's going to be 2.4. Negative 14 minus 2.4 is going to be negative 16.4. And then finally, negative 12 minus negative 3.2. So we're actually doing negative 12 plus 3.2. So that's going to be negative 8.8. For the next couple problems, we're going to be solving matrix equations for these missing letters, A, B, C, and D, that are kind of scattered throughout here. So the basic idea is that for matrices to be equal, remember we said they have to have the same dimensions, which these do, otherwise this problem would have no solution. They have to be the same dimensions, and we have to have the same numbers in the same positions. So basically what that means is we have to set the elements in the same positions equal to each other and then solve each of those individual equations that gets generated. So for this problem, you ought to be actually creating 4 different little mini equations out of this and solving each of them. Pause the video and see if you can find the values of A, B, C, and D. Alright, so we'll start setting things equal. We'll set A and 4 equal because those are in the same position. And doing that actually automatically solves for A. A equals 4. Cool. We'll do the same thing with B and negative 7. Those are going to be equal to each other. Next up, we've got 2C. That's equivalent to 8. Now this one we have to go a little further to solve, so we can divide by 2. So C is 4. And then finally we have D plus 4 equals 6. Subtracting 4, we get D equals 2. For this next problem, we've got another matrix equation. There's a little bit more going on in this one. For example, the left side is not just a single matrix that's with the same dimensions as the right side. So a good word of advice here would be to simplify each side to a single matrix first, and then solve the matrix equation. So with that in mind, pause the video and try this one out. Alright, so the only one that needs to be simplified is the left side here, because that's got more than just a single matrix going on. For PEMDAS, parentheses happens before anything, so this stuff inside parentheses should probably be taken care of before we mess around with this 4. I mean, you could distribute the 4 to both of these, but I'm going to add these first. So adding these two matrices together, we've got negative 2a plus 3. I can't really do anything else with that, so I'm just going to call it negative 2a plus 3. And I'm leaving the 4 here. I'm also leaving the stuff on the right side untouched. Next up, we've got 5 plus negative 6. That's negative 1. Negative 4 plus 7c is just negative 4 plus 7c. These are not like terms. Can't combine them yet. And then 2 plus the 1 in the lower right gives us 3. I still need to also distribute this 4, so I'm going to go ahead and do that. If I wanted to, since this is an equation, I could divide both sides by 4, and that would be okay as far as it went, but then I'd end up with something weird like B and D divided by 4 over here. So I'm not sure I really want to bother doing that. So just multiplying 4 on the left side, we're going to have negative 8a plus 12 for that upper left, and then this is going to become negative 4. Down here we've got negative 16 plus 28c, and 3 turns into 12. Now I've got a single matrix on each side. Let's set each element equal to its corresponding element. So negative 8a plus 12 equals negative 28. So subtracting 12, we've got negative 8a equals negative 40. So then a dividing by negative 8, a is going to equal 5. All right. Next we have negative b equal, or negative 4 equals b, which solves itself. Negative 16 plus 28c equals 40. So adding 16 over here, we've got a 56. And then dividing by 28, we've got c equals 2. And then finally, 12 equals d, which also solves itself. For our last problem, we've got a little real-world application here. A high school district track and field organization used the same standard qualifying times for its district championships in 2 consecutive years. And then the tables down here show the number of boys and girls in 3 class levels who qualified in the 100-meter run in those years. They want us to organize this data into 2 matrices, one for each year, and then find and interpret a matrix giving the average number of boys and girls who qualified in each class. All right, so let's take a step back. The way this information is currently organized is we've got the boys in one matrix and the girls in another matrix. What they're basically asking us to do is put all the 2019 stuff in a single matrix and then do the same thing for all the 2020 stuff. So let's go ahead and set up those 2 matrices. The one that has the 2019 stuff, I'm going to call that matrix A. So I'm going to give matrix A the 3 entries from the boys here for 2019. So the 18, the 23, and the 16. And I'm also going to give matrix A as kind of the second column here, the girls from 2019. So 21, 22, and 24. Next, let me do matrix B. That's going to be my 2020 stuff. So that's got the boys, 16, 25, and 12, and the girls from 2020, 15, 18, and 18. Now they want us to essentially average these 2 matrices together. So at this point, pause the video and see if you can figure out how to do that. All right, so if we're averaging matrices together, we're just adding up the matrices and dividing by the number of matrices, which in this case is 2. So you could think of this as essentially 1/2 times a plus b. Well, let's add a and b together to make this work out. So we're going to have 18 and 16 gives me 34. We've still got that 1/2 out there as well. And then we've got 21 and 15 is 36. 23 and 25 is 48. 22 and 18 is 40. 16 and 18 is 28. And then 24 and 18 gives us 42. And then we're just taking half of each of these. So we've got 17, 18, 24, 20, 14, and 21. So this concludes our first lesson on matrices. Hopefully you've enjoyed our time together here in the matrix. It's time to run. Till next time, Mr. Sutton signing off.